Well, hi, and thanks for joining me in my shop. Hey, it's been a couple of days since I've shot a video here. So I'm back in here now, and I'm looking at this Sparton radio, looking at the capacitors, thinking about a lot of intelligent comments I got about what to do with the radio next. And as you know, if you watched the last videos, you know the radio is actually working at this point, surprisingly well. Considering how old some of these parts are. And you can see I've changed one capacitor. And here it is here. And I was a little bit reticent about carrying on with more capacitor changes, even though it's obvious that there's a number of capacitors in here that really look to be in bad shape. Could be that those capacitors are not playing a very critical role in the operation of the radio. As I look at them here, I really don't know where they are in the circuit, and I have to sort that out, you know, looking at the schematic and figuring it out. So here's what I've decided to do, because I am quite firmly against the idea that for the sake of a repair, you should just go in and change all the capacitors out willy-nilly. I think that may introduce more problems than it may solve. So, but I am certainly willing to proceed on an evidence-based approach, and what encourages me on this radio is that this isn't full of original parts. You know, these are already replacement parts that have failed, and I'm pretty sure of that. And the reason is this is a Philco part. Pretty sure that's a Philco part here, and just the way the work has been done, it looks like, and this particular, these Hunt's capacitors, I understand these are a real giveaway for work having been done on the radio, and I think I learned before that these are not to be considered reliable. The Hunt's gotta go. And so I think what I'm going to do is I'm going to pick these. First I'm going to replace the cracked resistor, and I'm going to run the radio and see if that eliminates the crackly sound. Because another thing I really don't want to do is have a radio that's not working, replace a whole bunch of parts just kind of out of the blue, and then have it work, and then never understand what had actually gone wrong with it. You know, that's the fun part of this whole thing for me, is hunting down why things aren't working, and to just kind of, you know, grab the radio, change all the capacitors, and away we go. Now, I have done that. I have done that with other radios, and I have videos. If you poke through my videos long enough, you'll see videos of me changing all the capacitors in a radio. You'll even see a video of me changing all the capacitors in the radio, turning it on, and it didn't make one hill of beans worth of difference. And those were small radios where it's not a huge time commitment and the risk is small in terms of making an error and just introducing more and more problems. So that's the talk. So now I got to get into some action here. And I think maybe one of the things I'll do is get this big guy out of here. Get this big honker out of here. 16. This is a 16. Now that's interesting because there is a... Really, that's a 16? 16 millifarads. Microfarads. 16 microfarads, and there is a 16 microfarad capacitor in here, and it's capacitor C31, which is the one I thought was up on top here, the original one, which is a 16 also. Okay, so I'm pretty sure 31's on the top. Now this other 16 is probably a replacement for C32. Oh, which is an 18. It's even bigger, an 18. But I'll bet you that's what that is. And so I'm going to drive you nuts if I video all the time I'm going to spend figuring out what part is what here. So I'm going to be doing a lot of stopping, I think, on this video. Excuse me. While I figure out what each one is. But so I'll kind of focus on one capacitor at a time. Try to keep the full story without boring you with a lot of silence while I study schematics and stuff like that. So that's what I'm going to do with this video. Okay, and if I'm really tricky here, don't change the position of too many things. You won't even know when I've done a video edit. You won't even know through the powers of video. So one side of this capacitor is grounded right here. So I've cut that free. Oh, look at that. Okay. So what I see is that this capacitor has been spliced into this red wire. Most radios, they use red wire for the high voltage circuits, and not all of them, but most of them, fairly reliably. So if you just let your eye chase the red wire around, you can kind of get an idea where the high voltage is going. And of course, this is cut right into that wire. So that again indicates this is an additional capacitor designed to replace the original, I'm thinking 18. The original 18 microfarad capacitor. Let's see, it's connected to the speaker. Ooh, it's going to be a little tricky to figure out where that's connected exactly. So I'm going to have to trace this red wire a little bit here. Let's see, it goes up to this coil. And also comes way down in this point here. Looks like oh yeah, back on this cracked resistor I was going to work on. Yeah, I should be doing that cracked resistor for sure. Well, there's quite a busy terminal there. Holy smokes! Oh man, that's bad news. Big, large blob of solder. Let me show you. Let me show you what we can see here. It helps me see it too. So here's the cracked resistor. You can see the cracks in it clearly. I'll bet you that's the noisemaker, but we can't be sure. And it's connected to this terminal. Now, let me try and get a little more light on the subject here. Yeah, look at that. Look at the long twisted wire coming off there. Somebody twisted like an inch of wire together. And look at the solder. It doesn't really appear to have flowed properly. It's really not very well done, is it? And those two terminals, holy smokes, are they shorted together? And there's a whole pile of red wire coming into that end terminal. It's got a crack on the wire there too. That resistor's cracked right at the end. There's another resistor just in behind there, and I suspect it's cooked. It has a look like looks like the surface of the moon on it there. I think that guy's taking a beating too. So both those are going to go. And even these little guys down here, they just don't look the most healthy, do they? So that's what I'm working in. Goodness knows I can generate a short circuit in there. Where's that twisted wire going? Well, it's going somewhere. Looks like it's connecting to this terminal here. Let me look with my own eyes and see if I can figure that out. Okay, it shows up over here. Oh, look what it is. Surprise, surprise. Are those two Hunt's capacitors in parallel stuck down in there? You know what? Now that I've seen them on the magnifier, I know they exist, but I didn't even know they were there up until now. Ooh, there's another one buried way under there. Ooh, yuck. Fish that thing out. Yeah, right. And a myriad of bare wires all over the place here. And now, was it Jonathan? Who was somebody told me, Jonathan, I think it was, something else, that these wires here, these weird looking little short leads, almost looks like a hose out of an automobile engine, steel reinforced hose, that these are actually have very thin wires in them and act as either fuses or they're resistors. So I'm curious about those things. I've seen them in other radios and I thought they were shielded wires, but I've never been able to see the shielding on them, so I've always kind of really wondered what the heck are these things. So those are things to be a little bit curious about too. So I think I'm going to go after these resistors. Well, we'll leave this capacitor hanging out here. We already kind of figured that out. There's supposed to be two original filter capacitors in here, a 16 and an 18, and I'm sorry, 14 and 18? 16 and 18. And the 16 I see. 16 is easy to see. There's the 16 right there. Right there in the center of the shot. Where's the 18? Assumably it would also be in a can, but I don't see it, so I don't see where it could have been. Well, you know what? Look, see that hole? We're looking through that hole in the chassis. Let's look at it from the other side. There's the hole. I saw this when I first got it, and usually I think, I guess that hole was for some other, one step up model has another thing in there of some sort. But now when I look underneath it, and I look underneath this hole, okay, and looking at the hole itself, and right around the hole you can see a brownish stain. Okay, it's not the stain that's interesting. Here's the stain. It's not really the stain that's interesting in itself. It's the shape of the stain. It's pretty clear that that stain goes around something. It goes around something that's not there anymore. And what's it go around? It goes around the capacitor that was sitting here. So the capacitor's been removed and replaced by this big honker here. And that's why it's cut into this wire right at this location, because it's so close to the hole. It's so close to the original terminal point. It may even be the original terminal point kind of swung over, and it's all taped up and hanging, not the best thing. And and we're in Canada here. It keeps looking like people are using hockey tape, or a more common term would be friction tape, to tape these things up. There was no vinyl electrical tape perhaps at that time. Maybe that's the story. So it has this horrible clothy tape on it. Okay, back to the resistor. And didn't I say something about I wasn't going to bore everybody with too much talk? But ow! Jesus Christ! Oh man, Jimmy just got hurt. Son of a gun! Oh wow! What happened, Jim? I'm okay. I'm not dying here. Oh, man. Look at my hand there. Ah, I got pinched. Wow, that's just... I gotta run up and put some cold water on that. Excuse me. Okay, so that hurt very badly there. Look what I've done to my... Now, what the heck is that welt on my hand? I'll show you what happened here. I practically guillotined my hand here. And the reason I'm going to do this is a trick I used to play with my children all the time. Whenever they got hurt, the same way I just got hurt, I would get them to analyze what happened right away. What happened? What happened? I would get them to pay attention to what happened. So let's do that so I don't repeat this accident. So here's my little camera stand here. It's just a tripod, okay? I just reached around here like this, and when I turned this, I knew this was going to drop, but I just didn't think it would come flying down. And see what it did to my hand? Let's see. My hand was like this, and it came down about like this. Whack! Oh man! Hooah! That's how I hurt myself. So this is a trick I use with my kids all the time. Well, they'd be crying and whimpering and holding their knee, and I'd come over and I'd say, okay, so how did this happen exactly? What were you doing? And I would get them to analyze the accident, and it would distract them, which has worked for me here too. And at the same time, we would actually investigate the accident and figure out how it happened and what we could do to prevent it. And usually, you know, after about 2 or 3 minutes of being distracted, it's easy to forget about what's happened. It's you know, the human mind is well, it's not designed for the kind of world we live in, that's for sure. And one of the things the human mind does is it gets focused on whatever it's focused on. So when you're thinking about something, let's say you're thinking about your vacation that's coming. The more you think about it, the more important it will become to you. Well, vacations are important to begin with, and it makes sense to think about them more. So your mind will focus more and more on that, and less on other things. And that's good. That's good for all of us, except when it's something like this. And the pain is just about gone from that. Getting a nice blood blister there. Whew. So if you can distract your mind onto something else, it will raise the importance of what you're talking about and thinking about, and lessen the importance of the other thing it's no longer paying attention to. And the pain will actually recede, because your brain is deciding the pain's not so important. You got to spend time thinking about whatever else it is. So that's a trick I use with my kids all the time. And it really worked. And it just worked on me. Back to work now. Don't you guys ever turn the crank on your tripod and get your hand pinched like that now that you've seen me do it. So, and shame on me, I want to apologize for my outburst when I got my hand hurt there. I think I called upon a deity to come and deal with it, and I apologize for that if that offended anybody. But you know, once again, I don't generally edit my videos. I think I'll just let that go, because this is the kind of stuff I want to catch on video, believe it or not, is the real things that happen when you're doing this kind of work, including guillotining your hand with your video tripod. Okay, so what was I going to do? I was going to change this resistor, right? How much time have we gone by here? I haven't gotten anything done because I'm too busy. Talk. So let's first figure out what that resistor is. See if we can't figure out what all is connected to that busy point there. Oh man, I'm not looking forward to this. Resistors. It's not the resistor I'm talking about. It's just all the parts that are buried down in here. So, but you know what I found? When you do these, you end up doing them one at a time anyway. That's all you can do. So I should stop thinking about the whole schmozzle and getting unnerved by it, and just focus on one at a time. So the big dog bone resistor there. Body and dot. So it's brown, green, orange. Body and dot. Brown, green, orange. So that sounds like 16K, would that be? 16K? So now that's like the highest wattage resistor in the set. So I can just look down the list of parts, and under the resistors, just look for the highest wattage ones. It's going to be one of those. So we got a 2 watt, a 2 watt. There's a 5 watt. 15,000, that's it. One, the green is 5. So body and dot is brown, green, orange. That's 15,000, 3 watts. So 15K, 3 water. And I'm certain to have a good replacement for that. I'm just going to have to find it. Okay, and here we are right here. 15K. These are 5 watt resistors. Even though they look small, these are actually 5 watt resistors. So red, green, brown, green, red. Brown, green, orange. Boy, that orange looks a little reddish on these, doesn't it? but I'm sure that's 15K. So let's be stupid and take a measurement. .05, so that's right on. Now it'll be interesting when we cut this one out. We'll measure it and see what we get from it. You know, I'm going to cut this right off. It's just hanging in the way. What happened? Did I throw my cutters when I hurt my hand? What happened? Well, we'll use these. Oh, here's my cutter. There he is. Oh. It's not cracked so much as the paint is peeling off it. Maybe that's all that's going on there. Okay, let's measure this. See what we get. It's supposed to be 15K. Might be a little hard to get a contact here with it. Notice I've left my camera down low now. I'm not going to crank it back up and recharge the hand guillotine and chop my hand again, which has now gone to a fairly small blood blister. Oh. What's going on with that? What's happening there? I saw a flash of 19 a couple times. Oh, it's right on the, it's 20. It's reading exactly 20. That's kind of weird, isn't it? Dead on 20. Dead on 20, but if we just flex it a bit, oh, it's solid. I don't think I flexed it at all. Well, it has gone up to 20. Now, before we replace it, remind ourselves where it came from. It came from here to there. There's another resistor right in here. So, okay, if I look at the schematic now, and we find the 15K, which was R8. That's R8, way over there. Well, I'm getting a reading of about 800 ohms there. Yeah, 800 ohms. So is that the right resistor? There's other alternative paths in parallel with it, but I wouldn't imagine enough to bring it down to 800 from 22,000. That's a little surprising. So, what else could it be? Could be R5. Alright, great. R5 is the same value. Wait a minute, R5, R7. So R5 is a half watt and R7 is a 1 watt, but they're both 22k ohm resistors. That's not making this easy to figure out. What else could it be? Well, it goes, let's see, the resistor in question, where does it go? So I'm checking to see if either end of that resistor goes to the chassis ground. It doesn't look like it. So neither end of that one goes to the chassis ground. One end goes to a coil. Okay, so I'm going to just stop the video and carry on with this analysis, and I'll let you know what I figure.